Hi friends, through this video we'll learn one queuing problem. The problem is customer arrive at one-man barber shop according to Poisson process with mean inter-arrival time 12 minutes. Customer spent an average of 10 minutes in a barber chair. The question is what is the expected number of customers in the barber shop and in the queue. Calculate the percentage of time of arrival, can walk straight into the barber chair without having to wait. How much time can customer expect to spend in the barber shop? What is the average time customer spends in the queue? Before going to know, you have to identify the model of this queuing problem. It is mentioned according to the Poisson process, the inter-arrival time and the service is there. So therefore, the model is having the first quintile notation as M and M. And it is mentioned it must be the one-man barber shop. If it is a one-man barber shop, so the server must be 1. So therefore, you are getting the server is 1. And the capacity of the queue must be infinity because it is not mentioned any finite capacity here. And in barber shop, the queuing discipline must be first come, first serve. And how to recollect the formula of Little's formula? So that you have Ws is equal to Ls divided by lambda, Wq equal to Lq divided by lambda, Ws equal to Wq plus 1 divided by mu, and Ls is equal to Lq plus lambda divided by mu. For to do the problem, you have to know what is the mean arrival rate and mean service rate. It is mentioned in the problem itself, the inter-arrival rate having arrival time 12 minutes. That means the 12 minutes one person coming inside the barber shop, and also the customer spend an average of 10 minutes in the system to get a service. That means 12 minutes one person coming in the barber shop means we have to write the lambda value, that is mean arrival rate, for the unit time, that is 12 minutes one person. So therefore 1 minutes you are getting 1 by 12 person entering inside the barber shop. 1 by 12, it must be the inter-arrival rate. In the same way, the service rate must be 1 divided by 10 because 10 minutes one person is getting service. I am in need of the unit time, that is 1 minute. That's why I'm mentioning 1 by 10. We will answer for the first question. What is the expected number of customers in the barber shop and in the queue? Expected number denotes first we'll look for the expected number of customer in the barber shop. The expected number denotes the value L. The barber shop is in system. They are asking what is an LS. We'll look on the model. The model already we have, the name of the model is MM1 infinity FCFS. In the MM1 FCFS, the formula is here. The formula having the value of the LS is lambda divided by mu minus lambda. I will use that formula. LS is equal to lambda divided by mu minus lambda. Already you know what is a lambda and mu. Then you can calculate easily the value of that one. The lambda is 1 divided by 12 and the mu is 1 divided by 10 minus 1 divided by 12. Finally, you got the value of LS, that is the average number of customers in the system must be is equal to 5. We find out the L value, then easy to find all other values by the help of the Little's formula. The question is the expected number of customer in the queue. The expected number denotes L and it must be in the queue, so therefore the expected number of customer in the queue must be L. The formula of the LQ with the help of the Little's formula, it is mentioned here. You have to use the fourth formula what you have, LS equal to LQ plus lambda divided by mu. LS is equal to, we are in need of LQ. So therefore I am using the formula LS is equal to LQ plus lambda divided by mu. That is, you are getting the value already, value of LS is already been. The value of LS is already known, that is you have 5 and LQ and plus lambda divided by mu, that is 1 divided by 12 divided by mu. The mu must be 1 divided by 10. Reciprocal means you are getting 10 divided by 12, and if you are calculating this one you are getting 4.16. So therefore we find out the LQ value, that is the expected number of customers in the queue must be 4.16. And we will answer for the second question. calculate the percentage of time of arrival can walk straight into the barber chair without having to wait. That is, the person don't want to wait, they want to get the service directly. So therefore, how to get the service directly means the number of person in the system must be 0. So that is what must be the probability of the number of person in the system must be 0. That is denoted as P naught. The P naught value should be calculated looking like that. The formula is here. The value of the P naught in the first model is P naught is equal to 1 minus lambda divided by mu. 1 minus lambda divided by mu. That's all. So then it is very easy. 1 divided by 1 minus lambda divided by mu, and the lambda divided by mu must be, it is 1 divided by 12 divided by 1 divided by 10. So we got the answer. It must be equal to 1 divided by 6, and it is approximately equal to 0.16. But they are not asking what is the probability of zero customer in the system. Instead of that one, they are asking percentage. If you need of the percentage, you have to multiply this one with 100. So then you are getting 100 should be multiplied, then you got 16%. You have a chance to get 16% if the person doesn't wait and they are coming to sit in the barber chair directly for to get the service. And the third problem is how much time can customer expect to spend in the barber shop? How much time? Time means they are asking about the waiting time. So barber shop means it is system. Waiting time in the system. The waiting time of the system should be calculated with the help of the Little's formula, that is Ws is equal to Ls divided by lambda. Already we find out Ls, therefore you can use Ls divided by lambda. Then the formula says Ls is 5, already we find it in the beginning itself, Ls, and the lambda value is 1 divided by 12. Therefore you are getting the answer is 60. That is, the waiting time to spend in the barber shop is 60 minutes. 60 minutes. So they are asking the next question, what is the average number of time customers spend in the queue? The average number of time customers spend in the queue, it must be denoted as WQ, because waiting time in the queue, and it is also found out with the help of the Little's formula. WQ is equal to LQ divided by lambda. Lambda value we know, that is the LQ value is 25 divided by 6, and the lambda value is, we are getting 1 divided by 12. Answer is 50. So 50 minutes one person can wait in the queue to get the service. That's all. The answer is over. What you are looking here, first of all, you have to read the problem and identify what is the model here, and after one formula you have to know, and before that you have to find what is the lambda value and mu value. If you know any one of the value Ls, Ws or WQ, LQ, you can use the Little's formula to identify all other thing. This is the idea to do the problem in queuing theory. Thank you.